Hi there, my name is Dimitris Haralambidis. I'm a mathematics teacher, and in this video, we will see together how can we calculate a set's mean by just looking at this set's box and whiskers plot. At first, let us recall two things. First of all, what a box and whisker diagram really is. It's a 5 summary plot that tells us of 5 characteristics of a set. The set's minimum, maximum, Q1, Q3, and median values. Secondly, we should all remember, and we have seen it in another short video, that there is what we call the rule of 25%, which is the one you have in front of you. This rule states that from the minimum up to the Q1 set's value, there is approximately the 25% of the entire set's data. Then from Q1 up to median, we have another 25% of the sample's size. From median up to Q3, we have another 25%. And finally, from Q3 up to maximum, we have another 25%. So we've seen that the box plot can give us information regarding minimum, maximum, Q1, Q3, and median. What about the mean? How can we possibly calculate the mean by just looking at it? The whole key lies to the grouping process. Let's see an example. Let us assume that we have this number line, that we have this box plot over here, and now we will not randomly put it, but we will connect it to real values. Let's assume that this is 10, that this is 15, median somewhere here could be, let's say, 20. Here it could be 30, and here it could be 40. And let us assume as well that the set's size is 80. Based on the rule of 25%, and 25% of 80 is 20, we know that we expect in the interval from 10 up to 15, we expect to have approximately 20 values. In the interval of 25 up to 20, we expect another 20 values. From 20 up to 30, we expect another 20 values. And finally, from 30 up to 40, we expect another 20 values. And this is the process we just did. And through it, we managed to connect the box plot that we are working with a case of grouped data. And how would we be able to calculate the mean in such a case? Through mid-interval values. Mid-interval values. The mid-interval value of 10 to 15 is 12.5. From 15 to 20, it's 17.5. From 20 to 30, it's 25. And from 30 to 40, it's 35. Here, the frequencies remain 20, 20, 20, and 20. And finally, the mean in this case would have been 12.5 times 20 plus 17.5 times 20 plus 25 times 20 plus 35 times 20, and all that over 80. I will not calculate anything, but I will do some operations because I want you to see something. I will use in the numerator's place 20 as a common factor. 12.5 plus 17.5 plus 25 plus 35. And then I will divide it by the set's size. This 20 with that 80 will be simplified, and I will get a 4. So in the very end, we can conclude that the set's mean would actually be the mean of the mid-interval values of the classes formed between these 5 key characteristics: the minimum, Q1, median, Q3, and maximum. And that would be all. Once again, if you are given a box plot, all you have to do is group it using the 25% rule, and then calculate the mean as you would normally do in such a case. For any questions that might arise, please feel free to leave your comment below. As always, thank you for your time.